Alrighty. So, I gotta make sure I got the right microphone turned on because this thing likes to flip over. There we go. Now that should be better. Okay. So, last week we had geometry. So don't forget to make sure that you get the main concept and the lab extension turned in by those due dates, which is tonight. All right, so just make sure you get those done. Shouldn't take you long, shouldn't be more than like 14 questions or so. Should be okay. Just a lot of formulas, so make sure you go back and look over those. And then I think Fiona's in that group, so all right. Statistics. All right, so we'll pull up the notes and we're going to go ahead and start looking at this. All right. So let's start with some definitions. All right, now in the old textbook, this was section 8.1, so just ignore that. In the new one, I can't remember what it is, but it's definitely not there. So stats are a branch of mathematics that collects and studies data. Graphs are a visual representation of data made easy to read. And first we're going to look at circle graphs because they show the relationship of the part to the whole. So this was an example that I copied out of the book, the old book. All right. So it was a graph that said this was a monthly family budget. So here's how much of the graph was spent on things like rent, food, donating to charity, miscellaneous, transportation, and utilities. All right. So the types of questions that the book asked were things like, what's the biggest part of the budget? Well, that's the rent. It's usually going to be the rent. What's the money for utilities? Okay, so that's $200. How much for transportation or charity? So if it says transportation or charity, or if it was to say transportation and charity, put them together, just add them up. So you'll be looking at $650 plus 150 to make $800. And then, then the ratio of money spent for transportation to utilities. Technically, it's not allowed. I'll allow it this time. It's frowned upon by the college. Yeah, just for safety reasons. Yeah. Okay, so it's okay this time. Okay, ratio of money spent for transportation to utilities. So what that means as a ratio is take the money that is spent on transportation, which in this case is $650, and you're going to compare it to how much is spent on utilities as a fraction. So set it up as 650 over 200, reduce it, fraction, there you go. Now, of course, whenever they say ratio, they do want it as a fraction. So try to represent it that way, if that's the type of question that you have. This was an old question from a really, really old book, so may not have one like that pop up. Another example of a circle graph, this one here, was vehicle production in 2009, and this is a percentage-based circle graph. The other one had actual numbers in it, so it was like numeric. This one is percentage, okay? So it tells you, it did, because it's an old book, told you in the setup that the vehicle production in 2009 was 42 million cars. Now, these percentages mean that out of this 42 million, 32.8 came from China, 13.6 came from the US, 18.9 came from Japan, and so on. So then the questions that it was asking were ones like this. So number 31 said, what was China's production? How many cars did they produce? So that just goes back to using percentages. So you got 32.8 times 42 million, and make it a decimal, multiply it, so it comes out to be 13,776,000. So that's how you apply it. You just take these percentages and make it into a decimal right here and multiply it by how much it told you this graph is representing, and you get the number. All right, a question like 33 out of this old book says, what percentage is produced in Asia? So you have to take all the countries that reside in Asia, which in this case is South Korea, Japan, and China, and add their decimals or their percentages up, whichever way you want to go about it. So once you add it up, it turns out to be 60.1%. So 60.1% of 42 million is 25,242,000. 35 was a tricky one. It says, what was the percentage not made in China or Japan? So what that means is you're going to take all of the other pieces of the circle graph that are not this one or this one, and you're going to add them up. So that's going to be US, India, Brazil, South Korea, and Germany. All right, so you'll take all those percentages and add them up, and then multiply that total percentage by 42 million, and you'll have it. So yeah, two types of pie graphs that we'll look at. You got a percentage one where they give you a total, and they say, here is how many numbers or how many units or whatever it is that they're looking at represents, and then here are the percentages from the pie graph. All right, so there's that one. Okay, let's go to the third one here. All right, bar graphs. Bar graphs and line graphs. Okay, so bar graphs are helpful for seeing changes over a period of time. Double bar graphs are useful for making comparisons, and we'll look at some examples of those here in a little bit. A line graph is useful for showing trends over a period of time, and then a comparison line graph shows two or more line graphs together. Now the rest of these, these are examples from an old book that we don't have access to, so we'll look at some more examples of bar graphs and line graphs out of the picture examples that I have here in a little bit. All right, next part here. So a histogram. Okay, a histogram is similar to a bar graph, but the difference is, you know how like with a bar graph when you set it up, you might set up your bottom axis like, if you're looking at like monthly rainfall. It might be like January, February, March, April, stuff like that. A histogram would change that to look at intervals or frequencies. Okay, so for the intervals for a histogram, it might be like how much was it from January to February? How much was it from February to March, March to April, stuff like that. So it uses intervals and ranges and things like that. So each bar in a histogram is called a class interval, and the total in that interval is called a frequency. So again, we've got some picture examples to go help that out, so we'll pull those up here in a minute. All right. Okay, mean, median, and mode. Hopefully you remember this one from grade school. But if not, we'll go through it. So mean is, of course, you take all of the values that are provided in the number set that they give you, and you're going to add them up and divide by how many they are. This is also called an average. So if you have 10, like say if you have 10 grades for a class, you take all 10, add them up, and then divide by 10 to get your average. Now, of course, that is if it's not weighted. We're not going to cover a weighted mean because it gets a little confusing in that we're not going to cover it for a grade. I do have a post in there that shows you how to deal with a weighted mean if you want to use that to try to figure out what your GPA is. Median. Median is the value that has the same number of values above it as below it. In other words, it's if you put these numbers in order, it's the one sitting in the middle. If you have an even number set, you average the two in the middle to get your median, and if you don't, it's just the one sitting in the middle. And then of course, mode is the one that pops up the most. Now if none of them pop up more than once, then you would say that there is no mode for that one. So for instance, number 41 here, they looked at the different salaries for 10 employees working at this company. Okay, so they wanted the mean, median, and the mode out of this set of numbers. With mean, median, and mode, the best thing to do before you start finding any of these is to put them in order from least to greatest. Now, I went ahead and put them in order least to greatest for the notes, but in the textbook problem, they were scrambled. So it helps to put them in order that way, because when you put them in order, that allows you to find the median. You can't do it otherwise. So put them in order, add them up, all right? When you add all 10 of these up, it makes 21,570. You divide that by 10, and it says that the average salary of an employee at this company is, oops, didn't turn the marker on, is $21,157, $2,157. All right. For the median, put them in order. All right. So when you have an even number set, put them in order and you average the two in the middle. So after you put these in order, the two in the middle are 1,580 and 1,650. So once you add those two together and divide by 2, that makes a median of 1615. All right? So look at the average and then look at the median. Pretty different. All right? So keep that in mind for the question D that we're going to get to here in a second. There is no mode on this one. None of the numbers repeated. So if they don't, you would put no mode. So question D out of this old textbook was asking you, which of these numbers out of the mean and the median was a better indicator of what most people make at this company? All right. Oh, this was not put in order. I did it down here. Yeah, sorry, I got ahead of myself. I was looking at that 6,300 and I thought it was in order. So if you look at the vast majority of the numbers, most of them are in the, like between 1,000 and 1,900, basically. You've only got 2 of them that are above 2,000. So the question was asking which one is a better indicator of what the majority of people make at this company. Well, the mean was $2,157. 8 out of the 10 employees make less than that. So you would not use that as say, that's what the average employee makes here, because it's not. The median in this case is a much better indicator of what a random employee would be making here. So sometimes that happens. You might see questions like that. You may not, but it does happen sometimes. All right, so I just wrote in here the median is more indicative of what the typical employee earns, because the mean is skewed up by the person earning $6,300 a month. So you have these things occasionally called outliers, and they're data points that are a lot further away than where the majority of them is. So in this case, the 6,300 here would be considered an outlier if you were to put these on a number line, because it's almost 4,000 away from the next nearest one. Since median does not include outliers, it's kind of a better idea of what the majority is doing, whereas outliers are included in the mean. So if it's a really high outlier or a really low outlier, it will have an effect on it. All right, let's look at the quick review picture pages to get an idea of bar graphs and line graphs and things like that. All right. Okay. When I took these, they turned out a little bit blurry. I apologize. We'll just try to make the best of it. Okay. If you were to have a question that wanted you to make a circle graph from scratch and you were going to have to use a protractor, I'm not going to make you do that. But if it was going to ask you a question like, if you made a circle graph, how many degrees from the origin would this section make, or something like that. So here was the setup right here, all right? You had some work done on your car, and this is how much you spent on it. Was 8,000. That was the total down here. And then of that 8,000, here's where the money went. So 1,600 went to a leather interior, 2,400 went to wheels and tires, 1,200 went to the sunroof, and 2,800 went to the sport package. So the way that you figure out what piece of the pie graph this takes up, if you ever do have to make one from scratch, is you go over here and you take those individual numbers and do them as a ratio. So the leather interior right here was 1,600. So you set that up as a ratio of how much just that part was compared to how much money you spent total. So 1,600 to 8,000 is going to make 1/5 or 20% of your pie graph. Now, to measure that in degrees, you think, okay, a circle is 360 degrees. 20% of 360 degrees is 72 degrees. So that's why over here, for the leather interior, it says that the leather interior, this piece right here, is taking up 20. And if you were to, I'll try to trace this, if you were to put a protractor on that part right there, it would measure 72 degrees exactly. So that's how you get each of the pieces for this. So like if you're going to do the wheels and the tires. So 2,400 out of 8,000, that's 3/10, so 30%. 30% of 360 makes 108. So this piece here is going to measure 108 degrees, and in reference to the whole pie graph, it's going to make up 30% of it. All right, the sunroof was only 1,200. So 1,200 out of 8,000 is 3 out of 20, or 15%. So 15% of this is going to make 54 degrees because 0.15 times 360. So the sunroof is this section right here, and it tells you that it's 15% or 54 degrees. And then lastly, the biggest part of this was the sports package. It was 2,800. So 2,800 over 8,000 reduces to 7 over 20, or 35%. 360 times 35%, or 0.35, makes 126 degrees. So that's this part here. All right. Now again, the lab is not going to ask you to make a pie graph from scratch. It might ask you a question like, if this section of this pie graph takes up 20%, how many degrees does it measure? So you would just take that 20%, multiply it by 360, and get 72, and easy peasy. I've got this diagram here on this picture, but I've got it in another part in Moodle as well, and we'll look at that here in a minute. All right, a bar graph. Okay, so this is a bar graph used to determine the number of students who earned each letter grade. Okay, say maybe you had a test or a report card or something like that, and you're going to just kind of tally it up. Now, clearly, you would not display this to the class. If you did, you cannot use any, names or indicators of who got what or whatever. Kids are going to talk. You can't do nothing about that. But it's best just to kind of keep this for your own personal use. I wouldn't display this, just having public school experience myself. So, you might be asked to make a report like this for the county or whichever, but yeah. So, a bar graph. Notice some things about it that make it a bar graph. So first of all, do you see how there are spaces in between the bars? So in a bar graph, your bars do not touch. Technically speaking, sometimes you'll see a bar graph made where they are in contact with each other. Sometimes you'll see a histogram where they're not in contact with each other. But the rule states, things that make bar graphs different from histograms. Bar graphs need spaces between the bars, and histograms are supposed to be in contact because they're supposed to show a change over time. Bar graphs mostly just used for totals, tallies, things like that. Okay, so here, this down here below this says there were 3 that got an A, 7 that got a B, 4 that got a C, and 2 that got a D. So 3, 7, 4, and 2. All right. When you are making one of these from scratch, it's important to remember a couple of things. One, your X, which this is X here, and your Y axes, X and Y axes, they have to fit the bar graph. So in other words, if you're looking at grades of, say A to failing, then you would need to make sure that you've got all those grades going across the bottom. And since you're going to do a tally, once you've got your tallies, you want to make sure that you've got it high enough up the side to fit all of them. So in this case, the lowest number was 2 and the highest number was 7. So make sure that if you build it from scratch that you make it big enough to fit that. But yeah, bar graphs are usually just used for totals. Now, one thing also sometimes used in a bar graph is sometimes you will see a bar graph that has a line graph going over top of it across the peaks of the bars. Okay, and Excel will actually do this feature. You can have it make a bar graph and line graph combination. So this will show you how the totals are changing. Some folks like line graphs better, some folks like bar graphs better, some want to see them both. If you were to take this and just make it a line graph, then it would look like that. So you can do one, you can do the other, or you can do both. All right. So again, bar graph, line graph, you can put them together if you want to. Let's go to the next page. All right. So here's a line graph. Okay, the line graph below. I know this is really hard to read. I apologize. I thought this was a good picture when it turned out the first time, but apparently I was wrong. The line graph below shows the annual sales for the Fabric Supply Center for each of the 4 years. So again, a line graph, you can use it with a bar graph to show totals, or if you want to put it on a histogram to show changes in amounts for frequencies, you can do that too. So here's the graph. The graph has already been made for you, and the question is asking you to, got to turn the marker on. Find the sales in 2012. All right, so 2012, I can make this a little bit easier to see. Might be a little blurry, but it'll work. So find the sales in 2012. 2012 is right here. Here is the data point for 2012. So what helps it, what will help you sometimes is if you have any kind of straight edge, just kind of take it over to the y-axis so you can kind of know where it's at. The dot lines up with $500 on the left edge. Thereabouts. On our thing, it might be like 505 or something like that, but you can use 500 as an approximation. So it says that it lines up with 500 on the left edge. So 500 times 1,000 is $500,000 in sales. Because you can't see it because of the poor quality of the picture, but right here in parentheses, it says in ooh, that did not turn out good. In thousands. So when it says something like that, these numbers on the left get multiplied by that scale factor to scale it up. So if it was 750 for 2010, it would be 750,000. All right? They'll do that sometimes. Okay. Preparing a frequency distribution and a histogram from raw data. So these are, we're not going to use that one. That one's a little bit too tricky to explain. All right, yeah, here we go. Okay, so what they did was they set up the class intervals on the previous step by seeing how many times students landed within that score. They only scored it from like 9 to 20 or whatever. All right, so they measured how many people had scores in the 9 to 11 range, 12 to 14 range, 15 to 17 range, and 18 to 20 range. So in those ranges, all right, so an interval, you might also refer to it as a range. In those ranges, here are the frequencies of students that appeared in that range, or another word you could use is a tally. Okay, so if you set up, all right, I'm looking for how many students got a score in the 9 to 11 range. I got 1, 2, 3, 4 that landed in that range. So there you go. Okay, so once you've got your frequencies, or in most cases, they'll probably just give them to you. Then you can start making your histogram. Now remember, in a histogram, you see how there are no gaps in between the bars? So that's what makes a histogram different, is that the bars are supposed to touch because they want them to show how it changed from here to here, from here to here, to here to here. So your intervals are down here on the bottom, 9 to 11, 12 to 14, 15 to 17, 18 to 20, and those are the same ones that were lined up over here. Okay, so 9 to 11 had 4, all right, so that's going to line up with 4. 12 to 14 had 7, 15 to 17 had 5, and 18 to 20 also had 4. So we just line them up that way, and then just make sure that you know that this interval starts at 9, stops at 11. So if the next one starts at 12, that's why it's got to be right there in contact with it. All right. So that's how that's different. Bar graph has gaps because it's mostly just totals. Histogram is showing changes in amounts over time or in different intervals or ranges. Down here is some more exercise with finding the average. So these are test scores for Kathy West in her algebra class. So there's 8 tests, there they are. If she wants to find what the average is just for her test, she would take all 8 of these and add them up, divide them by 8, and then round it preferably to the nearest 10th to get a grade of 87.4 on her test. Add them up, divide by how many there are, easy peasy. All right. So weighted mean. This is not on your assignment. It's not anything that is going to require a grade from you. And I've got a diagram in Moodle that'll show you how to use it to find your GPA. We'll look at it here in a second. So a weighted mean is you multiply each value by its frequency, or in other words, if it shows up more or less or whichever, you give it more value. So this table shows a distribution of the number of school-age children in a survey of 30 families. So number of families that had 0 school-age children was 12. The number that had 1 was 6, 2 was 7, 3 was 3, 4 was 2. And this is out of 30. So find the mean number of school-age children per family, round to the nearest hundredth. So in other words, to find the value for this, you're going to say, okay, 0 or 12 families had 0 children, so 12 times 0, we're going to give that a value of 0. 6 families had 1 child, 6 times 1, we're going to give that a value of 6. 7 families had 2. 7 times 2, we're going to give that a value of 14. 3 families had 3 children. 3 times 3 is 9. 2 families had 4. 2 times 4 is 8. So there are 30 families, but a product of 37, roughly 37 kids. So 37 divided by 30 is 1.23 rounded. So the mean number of school-age children per family is approximately 1.23. So that's how they got those numbers. They used to say, what, the average American family had, 2 parents, 1 dog, and what, 2.7 children, something like that. So that's how they get those crazy numbers like that. Again, this is not something that you're going to be graded on because there's too much room for error there. Finding the median of a set of numbers. All right, so again, before you find the median, really before you find any of these, it helps to put them in order from least to greatest. So if you have an even set of numbers, there will be 2 of these that show up in the middle. Okay, so when that happens, average them and get kind of like an imaginary median. So if the 2 values for Kathy West were in the middle were 88 and 92, and she averaged those, so her median score is 90. And what that's saying is 90 is a better indicator of the majority of her grades. So if you look at it that way, 90, how many of them are close to 90? So close to 90, we'll say, within 5 of 90. So they're 5 out of her 8 are within 90. So median is a better indicator of what she's doing on her test than I think what was the other one, like 87 point something. So sometimes median is a better number. And mode, you don't need any help finding mode. You just put that in order, or put them in order, see if any of them repeat. Okay, so let's scroll down here a minute. Yeah, so here's a better quality picture of how to find the degrees of a pie graph. Okay, here's a better example of that question. All right, now let's go look at the previews for your homework. All right. Okay, so let's look at what kinds of questions we're going to be seeing here. All right, number one, use a circle graph to solve the problem. Circle graph below gives the inventory of the women's department of a store. What is the total inventory? So that one's not too bad. You're just going to take all of those numbers, or monetary values for each of their items that they have, and add them up. So just be careful, you know, 3 of these numbers are really close together, one's not, so just be very, very, very careful there. Number 2, circle graph gives the number of students in the residence halls at the state university. All right, write the ratio as a fraction in lowest terms of the number of residents at Brown to the number of students at Carver. So you're going to take the number, do that every time. You're going to take the number for Brown, however many students are in Brown, and then you'll set it up as a fraction over the number of students in Carver, and then, oops, I didn't mean to do that. And then you will reduce it. All right, easy peasy. Just make sure you don't set it up upside down. Don't do it Carver to Brown. It needs to be Brown to Carver. All right. I'm trying to think in the past of when people have missed that one. I think it's just they set it up upside down. Okay. Uh-oh, I did something wrong. What on earth just happened? Let's just open it back up. It's Microsoft Word. Ain't no telling what went wrong here. Okay. So that was number 2. All right, so number 3. A survey of the 7,247 vehicles on the campus of State University yielded the following circle graph. Together, what percent of the vehicles are either vans or convertibles? So again, since this percentage graph is representing 7,247 vehicles, it's saying this percent is convertibles, this percent's motorcycles, this percent's sedans, and so on. You get the idea. So when it says what percent of the vehicles are either vans or convertibles, take those 2 percentages, add them up, make it a decimal, and then multiply it by the 7247, and you'll be okay. Or actually, you don't even have to take it that far. Sorry, I should have looked at the answer choices. No, you don't even have to take it that far. You just have to put the percentages together, so it's even easier than I thought. My bad. Number 4, though, I think is the one I was looking at. So again, you've got a survey of 8,906 vehicles. Find the number of sedans. Round your result to the nearest whole number. So this is the same graph. It tells you what percent of sedans there are. You're going to take that percent, make it a decimal, multiply it by the total number of vehicles, and yeah, I was a problem ahead of where I should have been. Yeah, so 5% of 8,906 and you'll be okay. All right. Tatiana purchased a car for $23,456. Of that $23,456, she spent $29.32 for a sunroof, which was 12.5% of what she spent for the car. Find the number of degrees on a circle that represent the amount for the sunroof. So you're going to take the 12.5%, you're going to multiply that by 360 after you turn it into a decimal, and then that will give you the number of degrees that it would represent on a circle graph. All right, so 12.5 times 360. Okay, 6. Aaron purchased a house for $146,630. Of that, he spent $29,326 upgrading the original design. The upgrade cost was 20% of what he spent for the house. Find the number of degrees on a circle. So again, 20%. We've done that one several times. That shouldn't take you very long. 7. All right, refer to the double bar graph below, which shows the number of male and female athletes at a university over a 4-year period. So we didn't look at a double bar graph in the quick review. All the double bar graph is it's comparing two sets of data in the same X and Y variables. So if they want to look at how many athletes there were in each year of male and female, so you set up a legend. One pattern is male, the other pattern is female, and you're going to do the tallies for each year. Okay? So the question says, what was the amount of the decrease in the number of female athletes from 2004 to 2005? Okay? So again, this is an instance where it may help to take some sort of a straight edge, and you're just looking at female athletes. So if you're able to, just kind of, run that one that way for 2004, and then for 2005, run this one this way, and you kind of get an idea of what the totals were for it each year. If you're able to print this out, you can use a ruler. That will help. If you pull it up in Word, you might be able to draw a line that way. That may help too. So get the number for 2004, get the number for 2005, subtract it, you'll be all right. Pick the one that's closest to what you come up with. All right? Question 8. Use the comparison line graph to determine who needed more time to prepare for test 3, Jennifer or David. So in this one, it's also another one where there are two sets of data. One is Jennifer, one is David. The solid line is Jennifer, sorry, the solid line is David, dotted line is Jennifer, about messed that up. Okay, so the one that it's looking for is test 3. So you find test 3, and then you're going to look at David's number, and you're going to look at Jennifer's number, and you're going to see who needed more time to prepare, and there you go. No, that one ain't too bad. All right, come on now, let me scroll. Okay, this one, when I imported it into Moodle, the intervals kind of got a little bit askew. So 0 to 9 should be here. 10 to 19 should be here. 20 to 29 for that one. And then 30 to 39 for that one. So if you find a way to fix that one, that would help. For some reason, the picture shrank a lot, and because these numbers are part of that picture, I can't just like scale up the picture to make it match. If I tried to scale it up, the numbers would go even farther out. It's some things import good into Moodle and some things don't. That's what these questions are. They're screenshots of the questions in Moodle. So yeah. All right, now. Remember I told you sometimes they make a histogram and they forget to put the bars together? This is one of them times. They were supposed to put the bars together for this histogram. Either that or they had a pre-built bar graph and the book company said, we'll just use it for a histogram too. Could be that. Could be in production costs. But anyway, post office recorded the weights of packages sent on a particular day and used the results to construct a histogram. Use the histogram to solve the problem. So the question is asking, let me scroll this, how many packages weighed between 20 and 39 pounds? All right. So 20 and 39 is from here. 20 and 39 is from here to here. So you're going to take those two totals of those histograms and add them up. All right, because it's going from here, from the beginning of one to the end of another one. So you're just going to total them up, add them together. Okay. All right. Number 10, the batting averages of some of the players on the company softball team are all identical. I tried to fix it. It would not let me fix it. So, chalk it up as a trick question if you want to, but, this one won't take you a whole lot of time. All right, so that's the main concept lab. Now I told you at the beginning of the semester that we would eventually get to where the lab extensions are not going to be differentiated to groups anymore. We're going to get to where everybody's doing the same one. We're pretty much there because with the books that I had, it really didn't serve a purpose just to change the setup to the story because it's doing the same thing. So question 1, how many degrees are in a sector of a circle graph if it is to represent 48% of the total, round to the nearest whole degree? So again, 48% times 360, there you go. Number 2, how many degrees are in a sector of a circle graph if it is to represent 3,036 out of a total 6,900? So for this one, you've got to set it up as 3,036 divided by 6,900. You're going to get an answer, and then that answer gets multiplied by 360 after you turn it to a decimal. So make it a decimal and then multiply it. All right, because this number here will be a percent, right? And so you have to make it a decimal, multiply it by 360, and that should get it taken care of. It's just like that car one that we looked at out of the textbook. So figure out what percent it is, make it a decimal, multiply it by 360. All right. What kind of graph should be used with 2 sets of data? 2 being the operative word. Okay, so use that to help you answer that question. Number 4, the local high school band wants to sell cookies to raise money. They surveyed 68 area stores to determine which type of cookie they should sell to make the most. In 10 stores, chocolate fudge was the biggest seller. In 10 stores, it was sugar wafers. In 7, it was peanut butter. And in 26, it was chocolate chip. And in 15, it was oatmeal raisin. Which measure of central tendency should the high school band use to make the choice? Now, if you notice on this, I cut out where it said weighted mean because it is not going to be that one. All right, we're not doing anything with weighted mean, so just ignore that. It's either going to be mean, median, or mode. So put these numbers in order. All right, so you've got 10, 10, 26, 7, and 15, I believe. So put those in order, get your mean, get your median, and then see which number is closest to the majority of the numbers, and let that one decide which one is a better measure. This one does have a mode, so that's an that's an option as well. All right. Okay, so there's those 2. Make sure you get both of those done before April the 2nd. Next week is Tri-County's spring break, so we will not be here at all. Here is the weighted mean that I looked at. We had an example previously that involved finding GPA based off of how many credits that you had gotten. So you can use that to figure it out too. You're better off probably YouTubing it though. Oh, here we go. Here it is from the new book. Yeah, applying weighted mean from the new book. Yeah, this is a much better example. I should probably just take that other one out. But it tells you, okay, if an A counts 4 points for your GPA, a B counts 3 points for your GPA, a C counts 2, D counts 1, and an F counts none, figure out what your GPA is. So let's say this semester you're taking a math, speech, English, computer science, and art history class. You got an A in math because the math class was worth 4 credits. The speech class is worth 3. You got a C. The English class is worth 3. You got a B. Computer science is worth 2. You got an A. Art history is worth 2. You got a D. Okay, so that means math, 4 times 4, 16. Speech, 3 times 2, 6. English, 3 times 3, 9. Computer science, 2 times 4, 8. Art history, 2 times 1, 2. So you're going to take how many points or how many credits you've acquired after you multiply it by the grade to get these numbers. Then, to find your grade point average. So here, like this 41 here, that is your grade points, okay? And then your grade point average is going to be divided by the credits, okay? So 41 divided by 14, your GPA is a 2.93, which, you know, that's almost a 3. That's pretty good, right? Art history kind of hurt you a little bit, not as much as it would have if you had gotten a D in math, though. That really would have hurt. So that's how you do GPA. So if you're ever looking at your grades in self-service, you can kind of, you know, use that to figure that out. Okay, so a couple of things before I turn you loose. I know we're 3 minutes over, you know, when I normally let you go. Section 8 assignments, they close on April 2nd, okay? Remember, next week we are not meeting. Campus won't even be open. Well, I think the library will be. The week after next, which is the 8th through the 11th, so for y'all it would be the 9th, I will be out of town, so we will not meet the 9th either, so I'm not going to see y'all for 2 weeks. I will, though, what I plan on doing, since we got to kind of finish up here, I'm going to go ahead and and I've already put it in, Section 9 will open the week of the 8th, integers. I will record a new video for y'all for this. I mean, I'll probably record it one day this week and upload it in there. So it'll be up here towards the top. The video I'm doing right now should be uploaded sometime tonight, so you can go back and watch it later. But even though we will not be meeting the week of April the 8th, you will have an assignment that you have to do. And before you do statistics, remember that, if I can get to it, I got too many videos in here. Main Concept Geometry Lab 7 is due tonight, and both of the extensions, whichever one is yours, they are also due tonight. So you should have 2 things due tonight. Make sure that you get that done before you start working on Section 8. That way you don't fall behind. All right, we kind of burnt through that one pretty quick. Any questions about bar graphs, histograms, pie graphs, mean, median, and mode? Yeah, this video will be up. You can use it. If you're still stuck, you can always go in and check out YouTube. That's not going to hurt my feelings one bit. So, all right. I've kept y'all long enough, so have a good rest of the evening.